Algebra 2, Chapter 5, Section 4 review. Factor each expression. Okay, number 7. First thing we're going to do, let's set up our x. Remember, the top is our a times c and our bottom is our b. So our a times c is 2 and our b value is 3. So we're looking for a factor of 2 that has a sum of 3. Well, that would be 2 and 1. Since our a value is 1, we can just write this as x plus 2 times x plus 1. All right, number 13. Okay, our a times c value is 2. Our b value is negative 3. So a positive number up top, negative number at bottom tells me both of our factors have to be negative. They have to be a product of 2 and a sum of negative 3. So negative 2, negative 1. Again, our a value is at 1, so we can just write x minus 2 times x minus 1. Okay, number 19. My a times c value is negative 14, and my b value is negative 5. So if you notice, my top number is negative, my bottom number is negative. That means the only way I can get a product that's negative is I have to have a negative and positive number. And since my bottom number, or the sum, is negative, the negative number needs to be bigger. So two numbers that have a product of 14 and sum to negative 14 and sum to negative 5. So I can think of negative 7 and positive 2. So since my a value is 1, I can write this as x minus 7 times x plus 2. All right, 25. Here we go. This one's cool. So let's start with our a times c value. Oh, I have a number for my a value, so that's going to be 3 times 36. So that's going to be 108. And a product of 108 and a sum of 31. All right. So they're both positive. So we just got to look at our factors of 108. Okay, if you don't see it off the top of your head, just start with 108. That's not going to work. 2 and 59. 3 and 36. 4 and 27. Okay, what do you notice? 4 and 27 is going to work, isn't it? So 4 and 27. All right, let's look. My a value, unfortunately, is not 1, so we're going to have to rewrite it, and I think we're going to have enough room to do it right here. So I'm going to write 3x squared. I'm going to replace that 31x with my two factors. So I'm going to say plus 27x plus 4x plus 36. So you see what I did? I split that 31 up with the two factors. Okay, so now I'm going to group the first two terms and the second two terms. The first two terms I can factor out of 3x. When I factor out of 3x, I'm left with x plus 9. On the second set of terms, I can factor out a 4, and I'm left with x plus 9. Okay, so since my two groupings are the same, by distributive property, I can just sum the two factors in front. So I can rewrite this as 3x plus 4 times x plus 9. Easy enough. 31. Okay, 3x squared plus 7x minus 20. Okay, so my a times c value is going to be negative 60. My b value is going to be 7. So I need two terms, a positive and a negative, that have a product of negative 60 and a sum of 7. So I know I have to have a positive number and a negative number, and I know my positive number has to be greater. So, okay, we don't see this off the top of our head. Let's see. Let's say we just don't see it. Okay, so let's start with our factors starting with 1 and 60. So it'd be negative 1 and 60. So that'd be a sum of 59. That's not going to work. So we know negative 2 is not going to work. Let's start with negative 3. Negative 3 and 20. Well, that's going to give me a sum of 17. Closer, but not where we want to be. How about negative 4 and 15? That's going to get closer to an 11. So let's go negative 5 and 12. That gives us 7. What do you know? That's what we needed. So negative 5 and 12. So again, the a value is not 1, so we're going to have to rewrite it. 3x squared. So we're going to replace, I'm just going to rewrite it right here. 3x squared plus 7x minus 20. So we're going to replace that 7x with those two factors. So let's rewrite it. 3x squared plus 12x plus negative 5x plus 20. Let's group the first set of terms and then the second set of terms. I can factor out a 3x on the first one, get x plus 4. I can factor out a, sorry, that's minus right there. I can factor out a negative 5, and I'm going to get x plus 4. Again, since the groupings are the same inside the parentheses, I can sum these and come up with my distributive property. So I can get 3x minus 5 times x plus 4. So that's number 31. All right, number 32. Okay, looks like perfect squares here. So my a value is x, my b value is 1, and I have 2ab, which is going to equal 2x. So I can just rewrite this as x plus 1 squared. And if you don't see it, you can still factor it. Okay, remember, the rules on perfect squares is the first term and the last term have to be a perfect square. Well, x squared is the square root of x squared is x, and the square root of 1 is 1. So that's how I got my a value and my b value. Because remember, it's going to be a squared plus 2ab plus b squared. You got to remember that. Okay, here we go. Number 46. Refer to the diagram at the right. A machine will cut a small square of plastic from a larger square. Write an expression for the remaining area. Okay. Well, what is the area of this square, of the big square? Well, the area of the big square is x squared. The area of the smaller square would be minus 4 squared. So can I factor that? Absolutely. Could I say this is the same thing as x plus 4 times x minus 4? Yes. So do you see that? The big square in green, that whole area is x squared. Let's do it yellow. That whole area is x squared. This whole area right here is 16. So it'd be x squared minus 16 or x squared minus 4 squared. And remember, our products of squares are a difference of squares. All right. Number 48. The rectangle of the area of a rectangle cloth is 6x squared minus 19x minus 85 centimeters squared. The length is 2x minus 5. Find the width. Okay, so let's see if we can factor this thing. So for this term, my a value is 6, my b value is negative 19, and my c value is negative 85. Okay, so let's see. What's my a times c? That's going to be 6 times 85, so it's going to be negative, what is that, 510? My b value is negative 19. So I need a positive and a negative number. That's going to give me a product of 519. So let's do this, or 510. So I can break down negative 510 to 6 times 85. Well, so let's prime factor that. That's going to be 3 and 2. I can do 5 and 17. Is that right? Yep. So I'm looking for products I can do these things together. So 2 times 17 is 34. And 3 times 5 is 15. So if I subtracted those, I'd have a difference of 19. So I need negative 34 and positive 15. So let's rewrite this thing. Again, I'll just start with, since I have enough room, I'll just rewrite the whole thing here. So I'm going to go 6x squared. Instead of minus 19x, I'm going to replace it. Well, I'll just write minus 19x minus 85. I'm going to rewrite it as 6x squared minus 34x plus 15x minus 85. Okay. So let's see what I can do. I can group these two terms, and I can group these two terms. The first one, I can definitely pull out a 2x. So when I pull out a 2x, I'm going to get a 3x minus 17. The second term, I can pull out a 5, and I'm going to get 3x minus 17. So I can regroup these as 2x plus 5 times 3x minus 17. Well, if that's the area of the rectangle and I know the length is 2x minus 5, the width must just be 3x minus 17. Okay, you see I got that? This was the area. All this work right here was the area. Okay. Moving on. Number 49. Refer to the diagram at the right. Suppose you cut a small square from a sheet of cardboard. Write an expression for the remaining area. Factor the expression. All right. Well, what is the big square? What is the side of the big square? X plus y. So the area of the big square, if that's one side, would be x plus y squared. What is the area of the smaller square? Y squared. So there we go. It would be x plus y squared minus y squared. So let's factor this out and see if we can do anything. What's x plus y squared? Well, that's going to be x squared plus 2xy plus y squared. So now we're going to subtract y squared, aren't we? So I can rewrite this as x squared plus 2xy, which I can rewrite as x times x plus 2y. So there we go. That's the factored expression. If these all make sense and you kind of understand the process, you're going to do absolutely fine on this test. Good luck.